Hi everyone. Today I'm going to take a seminar on the topic machine learning for IoT health monitoring applications. I am delighted to welcome you all to this seminar on machine learning for IoT health monitoring. As we all know, the Internet of Things has revolutionized the way we interact with technology and has made significant contributions to various industries including healthcare. With the advancement in IoT, we now are capable to monitor and analyze health data remotely in real time, leading to more accurate diagnosis, personalized treatments, and better healthcare outcomes. However, the amount of data generated by these devices can be overwhelming, making it challenging to derive actionable insights from them. This is where machine learning comes into play. By using algorithms to identify patterns and relationships in data, machine learning can help us make sense of vast amount of health data collected by IoT devices. Machine learning models can learn and adapt to new data, allowing for more accurate predictions and insight over time. In this seminar, we will discuss how machine learning can be used for IoT health monitoring, the challenges associated with implementing these systems, and the benefits they offer to patients, healthcare providers, and the healthcare industry as a whole. Okay, here is the table of content. First, we go to the introduction part, then history, part 2, Internet of Things, health monitoring, architecture of health IoT, block diagram of a generalized IoT platform, use cases of uh, health monitoring IoT, then conclusion. Okay. Machine learning is the branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that human learns, gradually improving its accuracy. And Internet of Things describes the network of physical objects, things that are embedded with the sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. Machine learning and Internet of Things are two rapidly evolving technologies that are changing the way we live and work. Machine learning is a subfield of artificial intelligence that involves training algorithms to learn patterns in data, make predictions, and take actions without being explicitly programmed. IoT, on the other hand, refers to the interconnectivity of devices, sensors over the internet, enabling the exchange of data and information. Combining machine learning and IoT can create powerful applications that can make our lives easier and more efficient. For example, uh, by using sensors and machine learning algorithms, we can create smart homes that automatically adjust like a temperature, light, and other environmental factors based on the preferences of the resident. Uh, Similarly, in healthcare industry, IoT sensors can be used to collect patient data, which can be analyzed using machine learning algorithm to detect early signs of disease or to predict which treatment will be more effective. In industrial settings, IoT sensors can be used to monitor equipment and predict when maintenance is required, reducing downtime and increasing efficiency. Machine learning algorithm can also be used to optimize energy usage, reducing cost and environmental impact. However, there are also challenges in Comparing machine learning and IoT, one major challenge is the sheer volume of data generated by IoT devices, which can be difficult to manage and process. There are also issues around data privacy and security, as IoT devices can be vulnerable to cyber attack. Overall, the combinations of machine learning and IoT has the potential to transform many aspects of our life, but will require careful management and integration to ensure that the benefits are maximized while minimizing the risk. The healthcare domain is of great practical importance, and IoT opens a wide spectrum of opportunities to make it better. Numerous contemporary medical devices and sensors can be connected over various networks, which provide access to important information about patient's condition. Uh, this information can be used for multiple purposes, such as monitoring patients remotely, predicting illness and recovery through the greater insight into symptoms, and generally improving the diagnosis and treatment process via increased automation and portability. Here is the history of machine learning. The history of machine learning dates back to mid 20th century, when computer scientists began to explore the concept of artificial intelligence. The term machine learning was first coined in 1959 by Arthur Samuel, a pioneer in the field of computer gaming. In 1960s and 1970s, researchers developed algorithms for supervised learning, which involved training computers to recognize patterns in data by providing labeled examples. This led to the development of early machine learning systems such as perceptron algorithm, which would be used for image recognition and other tasks. In the 1980s and 90s, researchers began to explore unsupervised learning, which involved the training computers to find patterns in data without labeled examples. This led to the development of clustering and dimensionality reduction algorithms, which would be used for data compression and visualization. In the early 2000s and 2010s, machine learning became increasingly popular, fueled by the availability of large datasets and advances in computing power. Researchers developed new algorithms such as deep learning, which involved training neural network with multiple layers to recognize complex patterns in data. Today, machine learning is used in a wide range of applications, from image and speech recognition to natural language processing and autonomous vehicles. It has become a critical tool for businesses and organizations to analyze and make sense of the vast amounts of data generated by the modern technology. As machine learning continues to evolve, researchers are exploring new areas such as reinforcement learning, which involves training computers to learn through trials and errors, and transfer learning, which involves using pre-trained model to speed up the learning process for new tasks. The future of machine learning is likely to evolve continued innovation and development, as well as increased integration with other technologies such as IoT and blockchain. Uh, let's see the differences between machine learning and artificial intelligence. Artificial intelligence is where computer acts on their own, but machine learning is an application of AI, or let's say a subset of artificial intelligence. They act according to the environment. Computers observe and analyze. Systems display cognitive ability, predict based on previous patterns. Computers make decisions by their own. Here we have pre-programmed algorithms which work and predict the results. Okay, machine learning, a technique which enables machines to mimic human behavior. Um Artificial intelligence, a technique which enables machines to mimic human behavior. Machine learning, which is a subset of AI technique which uses statistical method to enable machines to improve with experience. Deep learning, subset of machine learning which makes the computation of multi-layer neural networks. Path to IoT. So this is the um, time timeline of IoT which we can see here. Now the concept of Internet of Things dates back to the uh, 18th 17th century actually, when researchers began to explore the idea of connecting everyday devices to the internet. However, it was until the 90s that the term IoT was first used by a British technology pioneer named Kevin Ashton. You see there. In the early days of IoT, most applications were limited to industrial and military settings, where sensors and other devices were used to monitor and control equipments. For example, in the early 2000, the US military developed a system called Smart Dust, which consists of tiny sensors that could be scattered across a battlefield to provide real-time data about the environment. As technology improved and costs declined, the IoT began to move beyond industrial and military settings and into the mainstream. In the 2010, the rapid growth of mobile devices and cloud computing made it possible to connect everyday devices to the internet and collect and analyze data in real time. Today, the IoT is used in a wide range of applications, from smart homes and wearable devices to transportation and healthcare. IoT devices can be used to monitor environmental conditions, track inventory and assets, and even detect and prevent equipment failure. As the IoT continues to evolve and researchers and development are exploring new applications and use cases. For example, the integration of IoT with artificial intelligence and machine learning has the potential to create more sophisticated intelligent systems, while the development of 5G networks promises to provide faster, more reliable connectivity for IoT devices. Overall, the history of IoT is one of the continuous innovation and development driven by advances in technology and a growing recognition of the potential benefits of connected devices and real-time data analysis. IoT and machine learning in healthcare. The adoption of IoT and machine learning revolutionized the way the healthcare industry works now, as it has greater potential and multiple applications, from remote monitoring to medical devices integration. In healthcare, the IoT and machine learning is used for interconnected healthcare devices like monitoring systems, sensors, machines, and detectors that can capture real-time health information. IoT devices are based on developing smart applications for medical usability like wearable modules, smart capsules, and sensory-based unit to assist medical personnel in gathering data. Models based on machine learning are used to analyze and detect several variations in health status of patient, suggest diagnosis methods and alternatives, thereby improving patients' health outcome. So this is a basic IoT health monitoring system. Here we have the patient where we are monitoring the heart rate and blood pressure through heart rate monitoring sensor and blood pressure sensor, and the data is gone through a wearable device, maybe like a smartwatch, to add to the mobile phone. Then the then the data, then the real-time data is uploaded to the cloud from the smartwatch. And in the cloud we have a data storage and analytic processing. Here the historical data are analyzed and categorized, and the analytical process, which include a machine learning algorithm, runs at the backend. The algorithm detect any abnormalities in the uh, state of patient in terms of heart rate or blood pressure. If it detect the abnormality, it then send an alerting system to the monitor, maybe like a mobile phone or an alarming system in the patient's room. And at the same time it also sends the patient health reports to the respective doctor. Architecture of a HIoT system. The implementation of IoT in healthcare originated from efforts to develop a remote patient monitoring system. The research on various applications of HIoT has since been growing consistently, and contemporary research aims at incorporating IoT into various facets of facets of healthcare, including disease spread control, effective automated diagnosis, and improved treatment. This is the basic architecture of HIoT. The architecture of HIoT can be broadly divided into four layers mainly: perception layer, network layer, platform layer, and application layer. This is the architecture of HIoT. This is the sensing layer, and through a wireless communication technology, maybe it may be Bluetooth or Zigbee or Wi-Fi, and it then send data to the edge or fork node where the analytics part takes place. Then passes to the network layer till finally it goes to the cloud layer where the data stores in the cloud. So in the network layer is responsible for transmitting data from the perceptron layer to the platform layer. So this layer can include a variety of technologies, including Wi-Fi, Bluetooth, uh, cellular network, and satellite communication. The network layer is also responsible for managing data traffic, ensuring data security, and providing reliable connectivity. And use cases of ML algorithm for monitoring. Continuous monitoring of a patient's health is gaining a lot of recognition, since it can not only drastically reduce the mortality resulting from sudden emergencies, but it also can promote awareness about one's own health and hence lead to a healthier life. Machine learning algorithm can be applied in a wide range of monitoring use cases, including anomaly detection, predictive maintenance, fraud detection, quality control, environmental monitoring, cybersecurity, and many more. Abnormality detection. In abnormality, ML algorithms can be used to identify abnormalities in data that may indicate potential problems such as equipment failures or security breaches. Abnormality detection algorithms can be trained on historical data, identify patterns that deviate from normal behavior. Predictive maintenance. In a predictive maintenance, ML algorithms can be used to predict when equipment is likely to fail based on the data from sensors and other monitoring devices. Predictive maintenance algorithm can help organizations avoid costly downtime and reduce maintenance cost. ML algorithm can also be used to detect fraudulent activity in financial transactions such as credit card transactions or insurance claims. Fraud detection algorithm can be used trained on historical data, identify patterns that are indicative of fraud. Quality control. Machine learning algorithm can be used to monitor production process and identify defects or quality issues in product. Here are some other use cases of machine learning algorithm. In the year 2000, we have a use case: cuffless blood pressure monitoring system using smartphone camera. The algorithm we used here was linear regression. It have the advantages as well as disadvantage. The advantage is that non-invasive and portable blood pressure monitoring. The drawback is that multiple high-end smartphone cameras were required, which increased the cost. And in the year 2017, we have continuous patient monitoring for stroke prediction. And the algorithms that they are used to was random forest. The advantages is that samples of multiple algorithms achieve higher performance. The drawback is that better IoT-based sensor system required for autonomous data collection, which is at that time has not been developed. In the year 2010, prediction of future glucose level through present monitoring data, and the algorithm have used was ANN. The advantage is that emergency diabetes cases can be predicted using this model. So this model can be used to predict diabetes cases which has an emergency nature. The drawback is that inaccurate for certain data changes. So we are predicting the diabetes case in real time. So there is an inaccurate for certain data change. The year 2017 fault prediction system and the algorithm used was NP. Advantage: multinomial NP is used, which outperforms all other algorithms. And the drawback is that research is forced only on hypertensive senior citizens. The year 2019 infant health monitoring system. Here we monitor the health conditions of infants, and the algorithm that used is gradient boosting. The advantage is that predicts whether preterm infant have bradycardia, allowing for early intervening measures. A drawback: study performed on a limited number of bradycardia patients, so the availability of dataset was lesser, so that for it will result in the accuracy of the prediction for another kind of patient. So to the main thing uh, when predicting some things based on some available data is that the availability of data set and how much data that we have and how well the data fit to our case. So here we only have a limited number of data from the patients. So then we have several companies which involved in machine learning, IoT, and healthcare industries. These companies are world-class MNCs, which have a separate R&D section for machine learning, IoT, healthcare. The first company is the Siemens, which is a uh, German multinational corporation. Then Abbott Laboratories, Honeywell Lifecare Solutions, and J&J. Siemens AG. With digitalization, smart infrastructure, and cybersecurity at its core, German technology giant Siemens AG is a leading provider of IoT-based healthcare solutions. MindSphere is Siemens' cloud-based open IoT operating system that connects medical devices and systems using advanced analytics. Abbott Laboratories, located in Abbott Park, Illinois, US. Abbott Laboratories is a top American healthcare company globally recognized for its top-of-the-line medical devices, diagnostic solutions, branded generic medicines, and a wide range of nutritional products. The company is rapidly integrating the emerging IoT technology into several of its patient monitoring, vital sign monitoring, and cardiovascular. Honeywell Lifecare Solutions. Honeywell Lifecare Solutions is the healthcare division of American multinational company Honeywell International Inc. This leading edge healthcare solution comprise a range of software, hardware, and IoT connected solutions that offer real-time patient care and monitoring and streamline clinical workflow. J&J, based in New Jersey, United States, Johnson and Johnson is a leading American company specializing in the manufacture of pharmaceutical, medical devices, and consumer goods. The company was recognized with the overall IoT Company of the Year title in 2020 for its top-notch IoT-based technology solution. Internet of Medical Things Systems. The use of fog edge computing architecture in the healthcare domain uh, typically deals with the design of remote monitoring solutions that leverage wearable uh, and field sensor networks for implementing protective, penetrative, and responsive systems. The Internet of Medical Things is the collection of medical devices and applications that connect to healthcare IT systems through online computer networks. The Internet of Medical Things refers to a network of medical devices and applications that are connected to the Internet and can exchange data over the Internet. IoT systems have the potential to transform healthcare by providing real-time patient monitoring, remote patient care, and improved access to healthcare services. Here, some of the examples of uh, Internet of Medical Things systems are wearable devices, remote patient monitoring systems, smart medical devices, telemedicine platforms, health monitoring applications. Overall, Internet of Medical, IMRT systems have the potential to revolutionize healthcare by improving patient outcomes, reducing costs, and providing more accessible and personalized care. However, the systems also raise concerns around data privacy, security, and interoperability, which must be addressed in order to fully realize their potential. Here is a three-tier based architecture of Internet of Medical Things. We have the edge, computer, and the fog layer. The edge layer contains a smartphone, smartwatches, or maybe any compact embedded system device. And we also have the different types of communication protocols like Bluetooth, Wi-Fi, uh, cellular, etc. The fog uh, node or layer contains field sensor network, local servers, and gateways which connect the cloud and cloud to the edge. So the cloud contains the main data storage element, or the data that are generated by various sensors are stored in the cloud. The cloud has an extensive area of storage where uh, daily real-time data is stored in the cloud for future analysis or future predictive applications or health reports of the patients, etc. Here is the machine learning cycle, or generalized machine learning cycle. The first step in any machine learning paradigm is the collection of data. First, we have to identify the problem that we are solving, or we have to define exactly what's the problem that we are solving. So by defining the problem, we get a clear picture of what all parameters or what all data set that we require to uh, train our model. So the first step is collection of the data. We collect data for training the ML. The data set may be of the type CSV, which is in the form of Excel, or a JSON type folder, which is a JavaScript type of data set, and it may also be in the form of images, audios, or signals, real-time signals. And after the collection of data, we are preparing the data. Preparing the data means transforming the raw data. The data set that we have collected may contain null values or duplicate values which may repeat over and over again. So that's where this will uh, result in the accuracy of our model. If it contains null values, duplicate values, etc., it will result in the accuracy, overall accuracy of our model. So we have to transform the raw data by there are certain collab or machine learning commands that we can use to filter out data. We need not need to uh, what we need not need to clear row by row or cancel the missing values or there are certain MATLAB functions or or programming functions that we can use to clear the data. After preparing the data or cleaning the data, we are now training a model. We are we are feeding machine learning algorithm with the sufficient data to learn from it. So here we train our model with the data that we have prepared. So through the data, the model trains and learns from what are things that in the data set. After training the model, we are evaluating the model, understand a machine learning model's performance. So by evaluating the model, we are evaluating its performance, how well the data predict for a given set of inputs and things like that. We are evaluating the model. After uh, so a good model has an accuracy range above 97.6%. Okay. After evaluating the model, then we are improving the model, learning from the past results and improving its output. So in order to reach a 99.99% accuracy, we are improving the model. So this is the basic machine learning life cycle in any machine learning uh, applications. Okay, this is basic neural network that which is multi-layer perceptron concept. Okay, let's see what a neural network is. A neural network is a method in which artificial intelligence that teaches the computer to process data in a way that is inspired by human brain. So we all know that human brain contain millions and billions of neurons which communicate with each other by sending electrical signals. So that same thing is mimicked in uh, mimicked by the concept neural network inside the computer. Here we does not have neurons as in the physical brain, but rather we have zeros and ones which we use to represent the neurons. So we have a input layer, we are feeding data to the input layer. These are neurons. These are neurons connected to other neurons, and the output layer which will give the result according to the data we are inputting through the input perceptrons. So let's see the applications of machine learning in IoT healthcare. So identify diseases and diagnosis is the first application. Then smart health records, which records the health health data of patients for future analysis. Outbreak prediction in the sense outbreak of epidemic or outbreak of any particular disease. uh, Wearable healthcare, where we have many kind of wearable devices, and activity trackers during cancer treatment. So we can track the activity and get a better treatment during cancer treatment. And medical alert systems. Yeah, that's one of the applications of machine learning, that medical alert systems which will alert when an abnormality in the data will result in an alerting system which will alert uh, whether if the patient is in a difficult kind of situation or the health of the patient is maybe critical. It will send an alert. Machine learning has the potential to transform healthcare by improving patient outcome, reducing cost, and enabling more personalized care. Uh, Electronic health record in electronic health. ML algorithms can be used to analyze electronic health records to identify Hmm, trends, patterns that may be useful for clinical decision making. For example, MI algorithms can analyze EHRs to identify patients at risk for readmission to or to predict the likelihood of a patient developing a particular condition. Overall, machine learning has the potential to improve healthcare in a wide range of applications, from disease diagnosis to personalized medicine. However, there are also challenges to the widespread adoption of machine learning in healthcare, including data privacy and security concerns, regulatory barriers, and the need for specialized skill and expertise. Wearable healthcare. This is a design flow of wearable healthcare and a care device as a tiny ML technology. We have the data source, model optimization, deploy model on the MCU. So then we also have the building of machine learning model, data source, public datasets or wearable sensor data. This wearable sensor data is a real-time data which is directly coming from the sensor nodes, and public data may be a already taken data which may be in this form of Excel file. And then we are building the machine learning model by pre-processing the data and the data splitting. So training model and splitting the data for training and also for evaluating the final results. Then we have model development and validation, then final model. Then we are deploying the model before deploying the model we have model optimization, like for compression and convert ML model for MCU. Then we have deployment of the machine learning model onto the MCU, and interface on MCU and interface result, which is the output of our model. So this is a study which was conducted by the authorities, which gives us the ethical ML in the healthcare industry. So 52% of people trust AI somewhat. So the majority of people trust AI, not completely, but somewhat. And 15 percentage of people trust AI completely. So by comparing 15 and 52, it forms the majority of people which we can say that they trust AI. 26 percentage of people somewhat distrustful of AI, and 5 percentage of them do not trust AI at all. They does not trust AI at any sense, and 2% have no opinion on AI in healthcare. So these are the advantages versus disadvantages of machine learning. And advantages of efficiency, data managing, data disadvantage, data acquisition, continuous improvement, time and space, consume time as well as the space, lots of applications. We have many millions and millions of applications in the field of machine learning in healthcare. Time consuming, trend identification, high error possibilities. So this is one of the main disadvantage of machine learning, high error possibilities. It's a tedious task to decode all the error that we have caused during the development process of our model, then pattern identification. Algorithm selection is also one of the difficult tasks that we faced on the development stage of machine learning or model, because there are a lot of algorithms that are available, but selecting the particular one that we have to incorporate in our particular application is a difficult process. We have to find two or more algorithms. We want to select two or more algorithms, have to write code for it, and have to uh, find the accuracy of those each algorithms, and then to we conclude that this algorithm has a higher accuracy, so we are selecting this algorithm. So algorithm selection is one of the difficult tasks in the machine learning lifecycle. So here we come to the end part of our seminar. Uh, so we have covered the major applications and systems where machine learning and IoT are proposed for a safer, accurate, and predictive healthcare system. Machine learning and IoT have a huge application in healthcare monitoring. Using machine learning and connected IoT systems, we can monitor people's health in sudden emergencies and can act accordingly. So there are huge applications in the field of machine learning in IoT health monitoring. Uh, so there we have a huge amount of previously collected data where we can uh, train our machine learning model for predicting different kind of applications based on the patient's dataset. So here are the references which I have used for the for developing PPT. You can use these references for your study as well. Thank you.